Alright, so we're going to be looking at water, pH, general hardness, kind of a alkalinity measure, and then nitrogen. This will be used for our eco columns. So, moving forward, we're going to talk about the hydrosphere, right? Because this is part of this is what we're measuring here. So the hydrosphere is a part of Earth's system that has water, ice, water vapor, water precipitates, and many of the most natural chemical reactions. And water is a really good solvent. So if you change any kind of Earth system, such as the amount of type of vegetation, the region, or natural land cover to like an impervious one that doesn't allow water through, it can affect the rest of the system. Rain and snow capture aerosols from the air. Acidic water will slowly dissolve rock. We've learned that other regular water can also just dissolve rock as well. And that as you get these dissolved waters inside there, you're going to have changes to the water because the water is no longer just H2O, but it has other dissolved chemicals inside there. The first one that we're going to look at is pH. We're looking at pH. We're measuring the relative amount of free hydrogen ions that are in the water, which determines the acidity of the water. So if you have more hydrogen ions, it's going to be more acidic, and you're going to be closer to the 0,1 area. If you have equal amounts of hydrogen ions, and OH ions, you're going to be neutral. And if you have more OH ions, you're going to be more basic. So H plus OH is H2O. So that's why in the middle, you'd have water, which is neutral. And it's on a logarithmic scale, so that means that every single time you go up one number, it's actually a 10 amount increase. So like a 1 is 10 times more stronger than a 2, which is 10 times more stronger than a 3, right? So then a 1 is 100 times more stronger acid than a 3. The pH values for your water depend on the geology, the soil, the vegetation, and what else is going in there, right? The air masses that are going to be creating the water that go into your water bottle may also affect it, right? So lakes and streams have pH values that range between 6.5 and 8.5, and oceans are about 8.2. Pure water that has that in contact there is a neutral value of 7.0. So this is just for you to kind of be clear on this. You have an acid that is H plus ion. Close your goddamn computer! Milas!
Look, I'm trying to set up
I am just watching what you're doing right now. An acid has an excess of H ions. It comes from the Latin word acidus, which means sharp or sour. A base is a solution that has excess OH ions. Another word for base is alkali. Neutral is where you have exactly 7.0 and no properties of an acid or base. And aqueous is a solution that is mainly water. Think about the word aquarium. Aqua means water. So here we have just an idea that in order for you to survive, you're going to want to exist in a certain pH. If you are completely in this area, right, you're going to survive. If you're in this area, you survive. However, there are some that like to live in a little bit more acidic. There are some that like to be in a little bit more basic. Mosquitoes won't survive if it's not they'll die if it's at this pH value. Here's the limits for perch. Here are fish that are beyond the limits. So the pH affects most chemical and biological processes. Has a strong so it's basically how toxic things are going to be, right? If it's too strong of a pH one way or the other. pH has a strong influence on what can live in the water. Aquatic organisms we just talked about where they can survive. And because they're sensitive to changes in water, pH scientists monitor this increase or decrease in pH. This is a picture of what happened to the Animas River, I don't know, like 5 years ago. There was a spill or drainage from the Gold King mine, and as a result, it ended up changing the entire river to this ugly brown color. Yellow was actually like more orange in this, and it was a lot more acidic, right? The Animas River between Silverton and Durango, Colorado, just really looked bad. So when you're determining pH, you're basically looking at A, the total amount of free hydrogen ions that there are in the water. It's often a ratio of hydrogen to hydroxide ions. Alright, so we're going to skip through this, but just so that you guys realize, this is what we're looking at, right? Our pH paper doesn't really go much lower than 6.4, but you can guess what that is. And for our values in the eco column, and maybe other places. You can just know if it's more acidic or if it's going to be in the basic range. General hardness is how much calcium, magnesium, and other ions are in the water. And sometimes this is referred to as total hardness. And you're going to have a range of it because it depends on what's dissolved in there. KH is carbonate hardness or alkalinity. And they're selling this alkaline water now. And it's how many carbonates, bicarbonates, like sodium bicarbonate, which is baking soda, right? It is a base. That's why it reacts with an acid to actually form water and some other salts, right? But basically, if you are have this, it acts as a buffer, right? If you have a lot of KH, and it's going to make sure that pH does not go too low. It's harder to change. Nitrate and nitrite levels. Nitrite stops the oxygen exchange of fish's bloodstream, so it causes them to suffocate. Fish are the only experience nitrate toxicity, will often breathe rapidly. The only safe nitrate level is 0, so if you're noticing these increase, that's bad for the fish. The nitrate level is converted to nitrite is converted to nitrate, and excess levels can be bad for your fish, and they aren't going to grow. So that's why you want to keep on changing it so that your nitrate levels can be a little bit better, but because you don't want them to die. Here's the nitrogen cycle. We will go into more detail about these as we move forward, but this is just showing. This is a biogeochemical cycle. As you remember, the majority of the atmosphere is made up of nitrogen, so it's important that we have things, right, bacteria that are able to fix nitrite, fix nitrogen that is used, that is in the air, and you can get it to turn it into something that is useful, right? So Nitrobacter, which is a bacteria, convert nitrate to nitrate through oxidation. You want that to be pretty low. Plants will use this nitrate to produce algae and plants. So you look at our eco column, that's happening. And then, of course, the ammonia is produced from fish is a waste product, so that's going to be creating NH3, and that's the nitrogen cycling into nitrite, which gets broken down, which is bad, right? Which needs to get broken down again. So it's important that we remove it. All right.